Okay, so our last day of triangle congruence criteria is really what this is. Up to this point, we've talked about SAS, ASA, SSS, and AAS. And we've also talked about how SSA and AAA don't work. Today we're going to discuss something called hypotenuse leg triangle congruence. And let me explain how that works right now. So, let's say I have a right triangle ABC and it has a longer leg with length 15 and it has a hypotenuse with length 17. They want the length of this other leg. Well, how do I find the third leg in a right triangle? How do I find that? Ooh, I know. It's a squared plus b squared equals c squared. Mrs. Fibber, how do you know that? Because I'm literally paid to know that. Pythagorean theorem, right? I got a right triangle. It's got three sides. The three sides fit into a squared plus b squared equals c squared. So x squared plus 225 equals 289. Subtract the 225. X squared equals 64. Square root it. And you get 8. There's the third side. Hurrah! Yay for me. Okay, now I've got another right triangle, XYZ. Okay, fine. XYZ. Its hypotenuse has a length of 17, and it has a leg of length 15. Find the length of the other leg. Wait, what? Find the length of the other leg? I just did that. Why do I have to do it again? Isn't y squared plus 15 squared going to equal 17 squared if y equals 8? Well, yeah. Mrs. Weber, why did you have us do that twice? That seems like a waste of our time. It's not a waste of your time, and here's why. If it were any other triangle, if I told you this is 6 and this is 7, find x, and then I told you this is 6 and this is 7, find x, are those x's the same? No. If you have other types of triangles, non-right triangles, given two sides, you can't find the third side. Nothing you do is going to help you. But if you have a right triangle, if you know two sides, because right triangles have that distinction of a squared plus b squared equals c squared, you're forced into having a third side that fits that theorem. So what's true about right triangle ABC and XYZ? Well, they're congruent, of course. And really, it's kind of sort of by side, side, side. But initially, I didn't have three sides. I only had two. So what if we did not know the exact length of the longer legs and the hypotenuse, but we knew that they had ones that were equal? So what if I had two right triangles, and I knew that this equals this, and that equals that, and I know that they're right triangles? Well, then the triangles are congruent because of the fact that really it lends itself to the Pythagorean theorem. So here's your hypotenuse leg triangle congruence criteria. We call it HL. So we have all these three-letter theorems and then one two-letter theorem. Given these two triangles, ABC and ABC prime, if I know that this angle and this angle are right angles, I know that AB the leg and AB the leg are equal, and that AC and A prime C prime are equal, then the triangles are congruent. So that means if you have two right triangles, and I look at how these are marked, I have an angle, a side, and another side. I almost have ASS. In fact, I do have ASS. Except the unique thing here is that my angle is a right angle. So what we want you to notice is that HL is really SSA, where the A is a 90-degree angle. All right, so HL is really when you get stuck with an SSA, but if your A is a right angle, you can call it HL. However, if you want to prove two triangles congruent by HL, you must first state that the two triangles are right triangles. Have to do that first. It's just a thing. Okay? So, how is that going to look? Here's how it's going to look. I'm going to come down here. I am going to do, I'm going to do number 1, and then we'll fill in the blanks, okay? So on number 1, let's show you a proof, then we're going to back up and do that other box. So here's my proof. I have statements. Well, I don't yet, but I will. I have reasons. My statements are that AB is congruent to CD, AD is perpendicular to CD, and CB is perpendicular to AB. And that was all given to me. So I should probably mark it AB, CD. AB and CB are perpendicular. Those are perpendicular. Okay. Got to prove these triangles congruent. Hey, those triangles butt up against each other in the middle, right? This AC guy is reflexive. As soon as you see reflexive, call that guy out. AC is congruent to itself by the reflexive property. Okay, then next, what have I got next? Well, wait, I have ASS. I don't really have ASS yet. I marked these with that little thing to show me that they're perpendicular, but I haven't stated anything in here to show my right angles, okay? So here's what you need to know. These next 2 steps go together. The 2 steps after that go together. So step 3 is to say, wait, if I have perpendicularity, I can identify right angles. Angle B and angle D are right angles. Reason being, perpendicular lines form right angles. Then number 4, if B and D were both right angles, then B and D are congruent because all right angles are congruent. Remember, those are always partnered. When you see perpendicularity, you have some partners. Then I can say, all right, now I've got AC and AC as a side, AB and CD as a side, and I have B and D as right angles that are congruent. I have ASS. But it's not really ASS because my A is a right angle, so I have HL. However, HL can't be proven until you first state that triangle ADC and triangle CBA are right triangles. Reason being, they both have right angles. Then finally, I can say that means triangle ADC is congruent to triangle CBA by HL congruence. So what I want you to get out of that is when you see perpendicularity, that yields 2 separate statements and reasons. Perpendicularity leads you to right angles that are therefore congruent. When you see hypotenuse leg, that leads to 2 statements and reasons because hypotenuse leg requires that you previously state that you have right triangles. So that's how an HL proof works. So let's back up for a second and talk about the things that work and the things that don't. What are our 5 triangle congruence criteria? Well, they are as follows. They are HL, which we just talked about. They are SSS, SAS, ASA, and AAS. Those are what you can use. So when you mark up your diagram and you look at what's marked and what's not, you need to see those things. If instead you saw ASS, not okay, you can't do that. If you see SSA, not okay, you can't do that. But if either of those were ASS or SSA with a right angle, you can do it, but you have to do it with HL. And then last but not least, the other one you can't use is AAA, because AAA doesn't work. Just angles don't yield congruent triangles. They create consimilar triangles. Okie dokie. All right. Last but not least, we have number 2. Here's what I want to do here. I want you to pause this video. Press pause with your little finger. Press pause on the video. I want you to try number 2, and then I want you to unpause the video, and I will very quickly go through it with you so you have like a checks and balances. Ready, set, pause. All right, so hopefully you're back. And you did this on your own, and your proof looks something like mine. So step 1, you should have those givens. Step 2 could be honestly anything from 2, 3, or 4 in mine. But I took step 2 to find those reflexive properties because they jump right out at me. Step 3, once I have my reflexive guy right down the middle, I said, well, this word midpoint showed up in my givens. So that means I can use the midpoint to say I have 2 congruent segments. And then last but not least, because perpendicular showed up in the givens, I know I have 2 steps here, 2 of them. One step stating that I have right angles, the following step saying that those right angles are congruent. You need 2 steps when you see perpendicularity. Then after that, I looked at my triangle and I said, well, I've got this, this, and that. That gives me a side angle side relationship, which proves the triangle's congruent. And then finally, because my proof statement said prove that angle equals angles, angle equals angle, by corresponding parts of congruent triangles are congruent, better known as CP, CT, C. All right, so we need a joke today. We need a joke. Let's see. The joke for today is going to be, why can't you hear a pterodactyl when it's in your bathroom? Why can't you hear a pterodactyl in your bathroom? Because its P is silent. You got to admit that one's pretty good. You're going to tell somebody that one. Okay, I'm done.